Hello and welcome back. So I've done a sim preview here of the scene that we just created, and I wanted to talk about few behaviors that we're getting by default just by doing the simple gradient to velocity thing. And if you look at the details here, the dissipated details, they're still moving. They're not, nothing has stopped at all. They're all getting internal velocity and moving in an interesting way. And this is a very important behavior that is missing by default in the smoke solver in Pyro in Houdini. And when you have an explosion, for example, and the velocity is gone, you don't get any external bubbling or any external movement happening in the sim. And a lot of times the reason the sim looks dull or flat is because there is nothing happening internally to the sim. And with this technique, we can always get details, even if we don't have velocity coming from anywhere or injected externally into the sim, we still get a lot of details. Now, the thinner the volume gets, the shorter its gradient is going to be, okay? And that information is also being used to drive the velocity. So as the smoke dissipates or gets thinner, its velocity is automatically tuned down based on that. And this relationship is really nice because we get that for free. We don't have to do anything. We don't have to do anything to treat those super dissipated areas or anything like that. So okay, let's continue. And what we're going to be doing now is working on that field. And what I want to do is actually let me show a high-res version of this. I don't know how much data I have. Let's see. It's very important to have the viewport display as fast as possible because that can add a lot of overhead to the sim time. You can see now trying to display this at 1024 is adding a lot of seconds to the sim. So we have to be very careful with how we're displaying the volumes. And that's why I had the HDR options both turned off. Actually, I should turn them off back. Cool. So this is the volume with density multiplied, of course. And if I let this keep running, it's going to keep splitting this, and I'll show this in a second. It's going to keep recursively splitting the volume into an infinite amount of details to its smallest voxel, which is 2 voxels because of that blur that we added. If we didn't have the blur, it's going to be much sharper and much harsher sim overall. So let me show you what I'm talking about. And this is just 38 frames, so if we let this evolve, it's gonna keep doing the same thing over and over. You can see this super fine detail here, getting that, and it just works. Okay, so let's continue on the stuff that is working. I'm gonna lower this back to 4, increase that back to 4, and let's do something in a Gas Field Vop to manipulate this guy. So the first thing that I always do is clear the velocity, any temp field when I'm done with them. This is a good practice. It's gonna save a little bit of memory, but it's not huge. And just side effects always does it in all its nodes, so I kept doing that. And we're going to use a gas. Let me remember. So we're going to use a gas linear combination, and this node can be used to do a lot of things. It can copy it can copy data into fields, inject them. It can multiply it by the time step. It's a very efficient node. And then sorry, it's a very useful node. I'm going to change the combine mode to copy, and the destination is going to be tempval, and then the constant is 0, so it's going to copy 0 to this, and that will clear out this field automatically. And let me rename this gas clear or clear temp val field. Okay, cool. So let's dive inside. And what we need is I want to access that temp val. Okay, so I'm gonna call in the temp val. This can get a little bit confusing. So let me explain what I'm going to do. We're copying the gradient into the temp val, TMP val, okay? And then we're going to process this field. We're going to change it and then export it back as temp val, same name, okay? We're going to process it here and then export it back as a temp val. So the original result is going to be copied here. We're going to process all of that. Forget that it contains the gradient. We're going to process that and use its gradient information to generate some new data and then export that back. And the reason I'm doing this is to save or avoid having to create two channels. I don't want to create two fields. I want to create one field. At the beginning, I store some information, and then I stream that information back from it, generate new data, and then export it back. We can create a new field and call it gradient, and then import both of them. But in this case, we can save one channel, which will make the sim use less memory. Okay, so the temp field, it's a 3 float, and what I'm going to do is I'm going to generate a noise based on this. So let me change this to a 3D float, and all I'm going to do is I'm going to export that, export that back again as a temp field, temp val. Same thing. And remember, this is, let me put a sticky. This guy, I contain the gradient information, which is like a normal for the volume. Okay, remember, we're going to use that gradient to generate a noise, which we've done in the previous videos in SOPs, and then we're going to export that into the same field just to save a field. Okay, and then it's gonna go through this. It's gonna get blurred using a radius of 1. We can actually lower this probably. And then it's going to get advected by the velocity, and then we're going to inject the temp velocity into the velocity. We're going to clear it again, and then it goes back. It reinitializes the field, it computes the gradient, we modify it, we blur it, advect it, and so on and so forth, and it keeps going over and over. And yeah, hopefully it makes sense. Let me make a copy of this, and let's play a few frames and see what we get. Okay, and let's make sure the noise is a 3D noise. Yeah, it's a 3D noise. Cool, so you can see now we're getting a noise pattern generated from the gradient that is changing every frame, and we're using that as the velocity. Let me increase the frequency of this noise, and let's increase the amplitude. Okay. We're getting some more different. We're getting completely different behavior, but notice what we're getting. We are getting a lot of details and a very realistic motion, a very realistic velocity field. It's not just the volume is not flowing through space. It's actually the velocity is coming from within the volume. Okay, and it's following the curvature of the mesh of the density field. And we can keep playing with this. Now we don't have a control over what's going to happen to this, but you can see we're getting a lot of details, which is again a very important part of all of this. Now let's do this. Let's go back, and I want to use the original gradient. I'm gonna normalize it because I don't want to. I want to have it go from 0 to 1 because I'm going to use that as a normal. Okay, let me check one thing. Okay, so let's normalize it, and then I'm going to add this here, and let's inject back. So what we've done is we've taken the gradient, normalized it, and then multiply it. Let me multiply it by noise, sir. I'm gonna multiply it by the noise, and then we're ejecting it back again. Now I'm gonna also add a multiply here because we may need to increase the gradient value, so we push it along its gradient more and have less noise in there. So let's hit play, and let me dive back inside in case we needed to change this. Let's hit play. Okay, cool. Okay, let's reduce this. Actually, you know what? Let me reduce this guy because I remember setting the source to 10. I want to reduce that, so let's... Okay, this is more natural. And again, this is just with without having any force coming from outside. Coming from SOPs, I mean. And this is going to continue forever, and it's going to add details to its maximum. It's always going to add reach the highest level of details that we can get from this volume. And let me go back inside the gas field Vop. I want to reduce the noise, and let's lower the frequency, make the details bigger, and maybe increase the gradient. I want to get more circular push, and now the noise is much bigger as well, so we're getting a different details, different shapes. Let's set this back to 2 maybe. This was 10, so let's see what we get here. Okay, cool. Alright, I'm gonna leave this as it is, and I'm going to restore the original velocity that we've had from the sim. So instead of having just sphere, I want to import that emission back. Okay, and now we have something pushing the volume, and then I want to start introducing the stuff that we created. So the first thing I'm going to do is I'm going to increase the gradient. It's pushing, you can see it's pushing more the volume. Obviously it's using the noise as well. So let's increase the amplitude of this as well. Yep, and now we're starting to destroy the entire volume within the sim. Now this stuff, I'm not so sure why this is happening. Could be because of the noise. Let me try one thing. Let's try to normalize this. Yeah, I think this is better, because the reason, if this vector is changing a lot between, let's say 0.001 on all axes to, let's say 100, because it's just a normal that based on the density, it varies a lot. And if we're using that, the noise can vary a lot between different areas. By normalizing it, we keep it between 0 and 1, so we know exactly what kind of pattern, what's the range of the noise that we can get. Okay, so right now we're keeping the original behavior of the sim, but I think we're destroying it too much. So let's reduce the normal force, which is this. Okay, and let's start introducing back more noise and see what we get. Cool. So you can see the pattern, you can see the noise itself and the size and everything. And remember, this noise generates between -1 and 1. It's not just positive values, and it will also push the volume in, not just outward. So let me change this to 5, 5, and 5. And I'm going to link them because I keep forgetting to change all the values. Cool, so now we're not distorting it too much. Nice, we're getting a lot of cool details now. And this is, we're also solving the mushroom cloud, the mushroom shape by doing all this. So we're gonna solve a lot of problems at the same time, including getting a lot of details, a noise that follows the curvature of the surface of the volume, and then getting rid of the mushroom shapes. Now, the main benefit of this method is that we're going to get an insane amount of details, no matter what the, well, we're going to get the maximum amount of details that we can get from the resolution, based on the resolution. So if we have this much, then we're getting that much detail. And let me go up and try and display it at a higher resolution. Cool, so even this, which is really low res, you can see we're getting a lot of interesting details. Even here, you can see there's a lot of variation, and here as well. Now, we are only using one noise pattern, okay, which is the default noise in Houdini. What if we start using different patterns? Okay, what if we use something else to disturb this volume? Then we can get some more interesting shapes. So what I'm going to do in this video, or actually in the next video, I'm gonna sim a high-res version of this. Just let it run for a couple of frames, and then you can see already we're getting a lot of cool details, and it's gonna start kicking in soon. And in the next video, we're going to learn about few patterns and see how they actually look like and how they can be used to disturb and deform geometry in general, and then we can apply the same technique to volumes as well. Thank you guys for watching, and see you in a bit.